want you. Oh, another piece box away. 'Cause you give me something that makes me scared, alright. This could be nothing, but I'm willing to give it a try. Please give me something, 'cause someday I might know my heart. And you only waited up for hours just to spend a little time alone with me. I can say I've never bought you flowers, oh, 'cause I can't work out what they mean. But I never thought that I'd love someone. No, I didn't, girl, 'cause that was someone else's dream. 'Cause you give me something that makes me scared, alright. This could be nothing, but I'm willing to give it a try. Please give me something. I might call you from my heart. It might be a second too late. The words that I could never mind anyway. Try, please give me something, 'cause someday I might know my heart. Know my heart, know my heart, know my heart. Yes, I will. Ooh, yes, you do. Yes, you do. Yes, you do. Something real, real good. La, 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 la. Oh, yeah.
So, have we collide? English, right? So, welcome. My name is Leon Soulier, and I'm from Siemens. And we are proud to host this event tonight in our field lab. Let me first introduce what a field lab does. I'll introduce why Siemens is on this stage and why you're looking at this bald guy with no blue shirt. And then afterwards I'll tell you something about Siemens, because we also see a lot of alumni here, and this all has to do with the reason why Siemens is sponsoring the Formula Student Team from Delft. This field lab is created just a couple of weeks ago and opened just a couple of weeks ago in a coordination between a couple of companies. So you see KUKA over there, which is the robotic arms. It's Airborne, which is the premises that we are on is from Airborne, which is a composite developer. They have a big factory behind that wall where everything is done manually. And Siemens, together with the education institutes, the university and some other schools, We had an idea to start the smart industry of the future, so Industry 4.0, as it is called in Germany. And that's the reason why we're actually here. It's not to develop something, it's not a production facility, it's an exhibition facility in which we are trying with all the people here, so students, but also from science and from business, to inspire them to create something that's the industrial automation of the future, which is quite nice. So when we started sponsoring the Formula Student Team about a year ago, I was looking forward to only one thing, which is to drive that magnificent vehicle, which I got to do on the sponsor thank you day. And there were a couple of things that were actually good. This machine was extremely fast. So I kicked it around the circuit as fast as I could. And fortunately, it did not break. Unfortunately, a professional driver came after me and beat my lap time, which was not that great. But so I still have the second prize standing on my desk in my office, which reminds me every day about that I became second and not first, which was terrible. So maybe this year, so we stretched the sponsorship contract for 1 year further, so that at least I have a rematch to see at the end if we would organize again a sponsor day. But probably we'll do it for longer. The reason why we started the cooperation with the Formula Student Team is actually because I hired Mickey, which is a former team manager of the team. And he did such a great job within our company that I was curious what the reason for his success was. And obviously he had a great university degree with some excellent working experience. But actually he told me that the reason why he's such an excellent team member and why he's so successfully in leading multidisciplinary projects is because of his experience at the Formula Student Team. So we hired the second team manager, or previous team manager from the Formula Student Team, and although they do not look anything alike, he's similarly successful. Which is to say, obviously, and Bas and the team told me that I'm talking to parents mostly today, is that this is a worthwhile experience for these guys. And although you think that they're spending 1 year doing nothing, drinking Coca-Colas and eating pizzas, which is probably true, it's also that they're gaining some extensive experience, and it makes them more valuable afterwards when they come into the labor market, as I just proven with the two guys that we hired in the team. So far for the commercial speech, right? The other thing is, obviously, when we hired these two guys, I thought we should hire more of these guys, and we should start at the basis. So Mickey and Steph hold my hand to the fire and said, the only thing you can do this but is if you spend some money on these guys. So we did, and then Bas and I met on the sponsor thank you day, and he said, if you want to do it next year, you can drive the car again. But also what we would like to do is to use your facility that we have here to do the design presentation in the city. And I said, well, that's okay, but then I need 5 minutes of your time as an investment to present what Siemens is actually doing. And especially what I will focus on is the reason why Siemens is sponsoring this and what the similarities are between it. I told you, or told the previous audience yesterday evening, because they were also in my focus area. I wanted to recruit all of these guys, so we spent almost until 1 o'clock to recruit these guys. Obviously, I consider your parents, so maybe you're not directly in my focus, but I also heard that parents have a big influence on the job decisions that their kids make, so at least that's what the kids told me, so that's that's the reason. So I clicked really fast through these slides and give you a brief introduction to what Siemens is actually doing. Who has knowledge of what Siemens does, or who knows Siemens actually? Can I see some hands? Well, I have a tougher crowd than I had yesterday. Yesterday a lot of hands came up. But Siemens has been there for quite a long time. This is Werner from Siemens, our founder. And probably where the people will know Siemens from is this, right? Washing machines or mobile phones. We sold or gave away 1.2 million mobile phones when you opened a Postbank account. So probably a lot of you people had these mobile phones, the first mobile phones that were out there, more or less. Do not look anything alike. And luckily as Siemens, or basically as Siemens, we do not do business to consumer anymore. So we're only focusing on business to business, and these are things of the past. Obviously you can still buy washing machines of Siemens or consumer electronics, but they're basically developed by Bosch. So what do we still do? And what decisions or what criteria are there in the world that we're trying to face? So obviously climate change, globalization, demographic change, people are getting older, and urbanization. More people than ever are living in cities, and this creates some challenges in the world that we have ahead of us, that Siemens has pioneering skills with all bright minds that work within Siemens that we're trying to recruit against the future to solve that. So we spent around 4 billion in 2013 on R&D with a lot of people all around the world, as you can see, to solve these questions. And then you think, well, what's actually the product that comes out of all these bright minds? So there's things like this. So this is the 9.3 Tesla largest MRI scanner in the world, delivered in Maastricht. Supposedly to win a couple of Nobel Prizes on healthcare because it's so extensive that fundamental scientific healthcare research can be done with it. So this is one. Other, obviously, probably known to at least to some of the students here, is the wind power offshore wind farm, Gemini, 85 kilometers out of the coast, so it's across the gradient of the Earth. You cannot see it from the coastline. And it supports 785,000 households. So that's quite a large wind farm. 6 megawatts turbines in there, so it's actually some nice features. But if the wind's not blowing, then we have a problem with our energy. So we also do steam and gas turbines. This is a 1600 megawatt gas turbine. We know that this car is fast and has a big propulsion, but 1600 megawatts is something else. And obviously, as you can do the math, this is about 1.5 million households in the Netherlands, only with this. So we also do Siemens Mobility. This is actually where me and my team are active in. So we deliver trains, we deliver streetcars, trams, metros, but also the rail automation that comes with it, which is the most challenging part, making sure that these trains do not collide and we do not have accidents. But we also do things like the sluices and locks, so sluizen and stuwen for Rijkswaterstaat, which is actually quite fun because the team members or the previous Formula student team members that are actually active now in my team, they have worked on this project as a tender. And it's funny to see how much similarities there are between the car or the development of the car and the development of a project like this, because it has mechanics, it has electronics, it has aerodynamics, it has water flow. We have to win a project like this in a competitive environment. We have to do a European tender, which means that the legislation or requirement specification is set, and we have to do the best possible solution for that within a time frame and also within budget to win it. And obviously afterwards we can develop a project, design it, produce it, and execute it. And then we have a little bit more service than you guys, because this is going to work for the next 50 years, and the car is going to work for about a year. So that's something different. But let me conclude by saying that there are so much similarities between the projects that are out there, which people that have 20 plus years experience are actually having trouble with doing this. And then we see these guys coming from school, having some experience, having a university degree. Obviously that's important, but also the important is how much they have already set their university and academic knowledge that they give into action. It makes them actually more valuable for what they have to do later in their jobs. And it gives them also the challenge to fail. Because in the car, if it does not work, you have 80 people there, all challenged and all working towards the same thing. And somebody will help you, making sure that the end result is met. In your career, this might not be true. So please use that to the students now. Please use that to your advantage. Fool around, try around, work hard. Afterwards, finish your university degree, and then come work for Siemens. That's basically the story. So I have the pleasure to introduce the new team member for the Formula Student 2016. Like I said, we met last year. He gave an excellent performance yesterday evening. I think it's hard for both of them to equal it this time, but we'll see if he will make it through. So give a big hand and a big applause for Bas van der Steggen. Thank you.
Mag je de klikken? Wow, thanks Leon. Thanks for the introduction and thanks for letting us use your facility. So welcome everyone. Welcome. It's so great to see so many of you made it over here. Welcome parents of team members. Welcome friends. Welcome other family. And a very special welcome to those of you who join us on the live stream. This presentation is broadcasted over the internet. Really great that you're tuning in and watching us, what we do. So, tonight we're going to do something very special. Something I'm really proud that I'm allowed to show to you guys. We're going to present the design of our latest Formula Student race car, the DUT16. The work of 75 team members for the past 4 months, and I'm allowed to present it to all of you. So I'm very proud. I'm Bas van der Steggen, and I'm team manager at Formula Student Team Delft. I'll be talking for the first half of the presentation, and afterwards I'll hand over the word to Tom Spoel. He's our chief engineer, and he'll go a bit deeper into the technical details of our new car. So, what are we going to talk about tonight? The first thing I'll be talking about tonight is the Formula Student competition, the competition that we compete in. I'll basically tell you all you need to know to understand what we do, what the most important rules are, what the competition looks like, so you can better understand what it is we try to achieve. And then I'll introduce you a very special team, the DUT16 team, the guys that have made the design of the latest car. And lastly, before I hand over to Tom, I'll talk a bit about life at Formula Student Team Delft. What is it like to be an engineer on the project? And then, the moment you've all been waiting for, we'll reveal the design of the DUT16, and Tom will talk about the design. The most important thing of the year is our team goal. We gathered all our wishes, hopes, and dreams, and tried to formulate one sentence with those. And the sentence is as following: we want to win all Formula Student competitions we attend. Now, winning a Formula Student competition isn't that easy, so you have to specify a bit about how you're going to do that. And we decided that it would be very beneficial to focus on the dynamic performance of the car, focus on systems engineering, good organization, and make sure that we have a maximum use of team and car potential. So now, what is the competition that we are trying to win? Formula Student is the biggest design competitions for engineers in the world. Over 500 teams from universities all around the globe participate in it. Currently there are over 8,000 students involved. This picture was actually taken at one of the competitions in Europe, Formula Student Germany. And as you can see, there are quite a lot of teams. 40 electric cars, 100 combustion cars. And there you can see us, Formula Student Team Delft, with the car we've built last year, the DUT15. So, the goal of the Formula Student competition is to design, or conceive, design, produce, and develop a Formula-style racing car. And then you take the prototype of that car to one of the Formula Student competitions, where you will compete against all those teams from all over the globe. And what you try to do at the Formula Student competition is you try to get as close as you can to 1,000 points. And you can earn those points into 2 categories. First, there are the static events. And that's basically presenting some details about your design. And then there are 5 dynamic events. A dynamics event is racing. It's showing off the performance of your car relative to the performance of the cars of the other teams. Well, first I'm going to dive a bit deeper into those first 3 static events. And to explain them, I've brought a couple of photos from last year's competition. At the top left, you see the cost analysis event. At the cost analysis event, you have to present a quite extensive analysis of all the costs that have gone into making your car. That's called the cost report. And here you can see the cost report we presented at the competition last year. There are over 400 pages in here, all accounting for materials that have gone into the car, production, cost of production processes. And you're supposed to show that you're good at 2 things. First, good bookkeeping. Secondly, making sure that you can make good trade-offs between design quality, and the manufacturing cost of your component. The second static event is the business presentation. At the business presentation, you have to present a pitch around your Formula Student car. You have to sell it to investors in the industrial world. The team with the best presentation wins. The last static event is the most prestigious. It's called design judging. At design judging, you'll present the design of your car to experts from the automotive industry, and you have to explain the reasoning behind your design choices and convince them that you have made the right choices in making the design of your car. But let's dive a bit deeper into the more exciting part of the competition, the dynamic events, the actual racing. The first dynamic event is called the acceleration. And it's actually pretty straightforward. You have to accelerate over 75 meters as fast as you can. And here I can show you how astonishing fast that is. Wow, that was really fast. Fun fact is that a typical electric Formula Student car, especially four-wheel driven one, can accelerate faster than a Formula 1 car. So for a brief second here, Suzanne, who was driving the acceleration, was faster than Max Verstappen. The second dynamic event is called the skid pad. At the skid pad, you have to drive the left lap and the right lap. As you can see, the skid pad event is all about the cornering performance of your car. And simultaneously, you have to show that your car is very stable and easy to handle so that you can go around the corner as fast as you can. Well, the most exciting part of the competition is the third event, to my opinion, which is called the autocross. Here it comes all together, all the performance of your car. You have to drive it on a really short and curvy circuit. You have to accelerate fast, brake fast, and then go around the corner fast as well. And here is how incredible fast that looks. Yes, that was real speed. The car actually is that fast. The next two dynamic events are basically an extension of the autocross. They're called the endurance and the efficiency, and they're held simultaneously. For the endurance, you have to drive for the autocross circuit for 22 kilometers without breaking down. Now, in a regular car, that sounds really easy, but remember, this car was designed and built by students, and reliability can be an issue. So the endurance is the race where you win it or you lose it. Simultaneously with the endurance is the efficiency event. At the efficiency event, you get points for using as little energy as you can. Now, you might be thinking that the endurance and the efficiency, that kind of contradicts. At the endurance, you want to be as fast as possible, but for the efficiency event, you want to use as little energy as possible, and that kind of means going slow. Now, we found a really inventive solution for that, and Tom will present it later to you tonight. So, the competition, Formula Student Team Germany, where we go to in the summer, has made an excellent video that shows you what being at the competition is like, and I'd like to present it to you now. Wow, 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 wow. And that's actually pretty close. There's just one really important step that we still have to take to get there. And that's build the car that we've designed now. So just a little milestone away from there. So now that I've introduced you to the Formula Student Competition, I'd like to introduce you to the most important part of the project. And that is our team, the DUT16 team. This is the best picture I could find of them. Not everyone is on here. And we're going to redo this picture tonight after the presentation. So let me show you a few statistics about our team first. Because there are 75 of us, 75 team members. Now that's just too many to introduce now, so I'll do that afterward at the end of the presentation. But I'd like to present two interesting facts to you. And first is the fact where we all come from. We all come from the Delft University of Technology, but from different faculties. That means that we are quite a multidisciplinary team. We have people from aerospace engineering, mechanical engineering, electrical engineering, and of course people from industrial design, applied sciences, and the Faculty of Technology, Policy and Management. And that's a really important thing, because you need to have many people from different disciplinaries to build something as complex as a Formula Student car. Another really cool statistic is where the team members come from, because we are quite an international team as well. As you can see up the map over there, we have team members coming from over 10 different countries all around the world. It's even so that some of the students actually travel especially to the Delft University of Technology to join the team. We are really proud of that, of course. To manage all these 75 students and make sure that we have a really efficient operation, we've introduced the department structure. So all of the team members are put in a department. And there are 6 technical departments. First, there's the vehicle dynamics. They determine the important parameters of the car and make sure that we'll actually design a fast car. Then the suspension department will put those parameters into practice in the design and make sure that we have a car according to specifications. The aerodynamics department further enhances the performance of the car by designing an aero package. The chassis department designs a structure that keeps the driver safe while driving. The powertrain department sets the car in motion and makes sure that we can enhance all that performance. And lastly, we have the electronics department. They design the wiring and all the electronic systems to regulate all the complex systems inside the car. And there's the 7th department, a really important one. We call it the management department, and they're in charge of everything non-technical on the car. So they are organizing events like this, and they're making sure that you actually have the logistics to make it to the competition. Now managing 7 departments and 75 students is a lot of work. And luckily, I don't have to do that on my own. I have 8 full-time students helping me out with that. And first, there's Thomas van der Hout. He's in charge of the powertrain. Damir Malewski is our technical manager. Koen Wendel, in charge of the suspension. Martijn van Hoorn, in charge of both the chassis and the aerodynamics. So he's got a really difficult double job to do, and he's handling it very well. We have Bernard Becker, designing the electronics of the car. Daniel van den Berg, the mind behind the vehicle dynamics. And last but not least, Jorik Bauer, managing the management department. Now, one thing you might be wondering is, how do I become a part of Formula Student Team Delft? And you, the team members, you know that, how we do that. We use interviews, but we take a very different approach to interviews. We use our top secret interview box. After tonight, it won't be that top secret anymore. I just realized that, because I've brought it here with me. What we'd like to do when we interview a new member, we'd like to grab a part from the car we've built previously and hand it to them. So you all can guess what this is. You can now all do an interview inside of your head. This is one of the parts that's inside a wheel. And we hand it to them and we ask them to reason with it. What kind of material is it made from? What kind of shapes do you see and what do you think it can be used for? Do you see anything else that's remarkable? And from that interview, we can see how someone reasons with such an object. We can see if they are creative, if they have the right background knowledge to work on the project. And during the applications, we look for someone who has this graph, these kinds of qualities. The first and most important quality we look for is motivation. Because motivation takes you to the end, it pushes you and makes sure that you have it in you to be a winner. Secondly, there's creativity. Creativity is extremely important because we like to do new stuff, invent new things, and make sure that we can come up with something that's better than something that has been designed before. Of course, you need to have sufficient time to work on the project, and you need to have knowledge. Now, although all of our engineers have obtained quite some knowledge from their studies at the Delft University of Technology, they have quite a solid background in engineering, they're still lacking a bit of knowledge. And that's because they actually never had experience with designing a car. So, in the first weeks of the projects, we try to get them up to speed with knowledge. And luckily, we have a couple of knowledge sponsors who help them out with that. And that's really important, because without the sponsors, you wouldn't be able to do what we do today. So, after after a year, we hope that our engineers look like this. They will have gained an enormous amount of knowledge and experience. They will have become even more creative. One thing they're lacking though, and your parents probably have noticed that, time. Because working on the project costs an immense amount of time, and especially if you're that motivated, you will just keep inputting the hours. So we can imagine that you hardly see them. As Leon said, we have something very special to thank our sponsors. The Sponsor Day, really important. So let me tell you a bit now about life at Formula Student Team Delft. What do all the engineers do all day? This is a time lapse shot at our office. And what you can see here is that it's actually quite busy. You see people talking to each other, collaborating, basically what we call interfacing, discussing about certain details of the car. And this is really important because a car has so many components that have to work together seamlessly in order to be effective. And there's only one thing you can do to realize that, and that's work together. And that's something that our team is really good at. Now, we designed a car in just 4 months. And 4 months isn't an awful lot of time to design a car. So you have to be really efficient. And one thing to do to enhance the efficiency of our team is we eat together every night, and we have lunch together as well, so the team members don't lose that much time on something as dining and lunching. And of course, it's a lot of fun to be together with all your teammates and discuss a bit about the project. Sometimes we notice that a lot of team members get so caught up in their work that they actually won't notice that dinner is served. They're just too focused on their designs, looking at their laptop screens. So we've invented a system for that. And we call it the lunch bell. And it kind of sounds like this, but then way louder, to alert everyone that dinner is served and that they have to come to the dinner table to eat together, to talk to each other, and basically discuss the day with each other. Now, something we realized as well is that lunch and dinner are not enough to have a satisfied engineer. You need to have something extra, and that's the snacks. Here you can see a picture of Joris Winkel, where you can get all sorts of stuff that aren't good for you, but they give you a sugar rush. We have drinks as well, so for when you get thirsty. And the really cool part about all of this is that the engineers pay for all of this themselves. We've invented a system, we call it Bliebgeit, to keep track of all the expenses that people make. So we can make sure that every euro we obtain through partnerships goes into building a car. And all of this results in one really important thing, and that's happy engineers. Here you can see Tom. He just bought a drink from Joris Winkel, and he's very happy, and he's ready to work until the late hours of the night. Now, not everything we do at Formula Student Team Delft is working. It's really important to take a break and relax as well. And that's why we organize a team weekend for all the team members. At the team weekend, we get to know each other better and go to a fun location and make sure that our minds are open again so that we're ready for the design phase. So, now that we've decided... Let's just skip that one real quick. Now that we've made a design of a really fast car, we still need something to enhance it, and that's a driver. Not just any driver, a really fast driver. And to find that driver, we do a driver selection. And driver selection basically looks like this. We take the entire team and we put them in go-karts. One time, for a second time, and then even for a third time. And we combine all the data that we gather from that. And then we'll see who has the most talent for driving in a Formula Student car. But it doesn't end there, because driving a Formula Student car is really different from driving a kart. It's way more intense, the accelerations are way bigger, so you have to be in very good shape. So you move into driver training. And at driver training, there are basically two things you have to do. First thing is you have to lose weight. Daniel, how much weight did you lose last year? 20 kilograms. And you have to do something else, and that's exercise. You have to make sure that your body is strong enough to handle the extreme forces that the car exerts on you. And once you've made it through driver training, we actually put you in one of the cars we've built in the year before, so that you can practice driving in a Formula Student car. And for Daniel, his first lap looked like this. Now, I made a promise to Daniel that I was only allowed to show this clip if I were to mention that he made it as a driver in the competition this summer, and he managed to set some excellent times. So, now, the moment you've all been waiting for, and I'm really proud that I'm here tonight to present to you the hard work of 75 of our team members. I hereby proudly present you, on behalf of the DUT16 team, the design of the DUT16.
Wow. What an amazing car. Ladies and gentlemen, friends, family, team members, and of course the live viewers, a warm welcome from my side as well. Today is a true milestone for the entire team. Today we will reveal the design to DUT16. We will show you what we've been working on so hard for the past 4 months. Let me take you on a ride through all aspects of the design and show you the really impressive specifications this car has. Before we move on to the design, first I want to say something about our design philosophy. As we want to compete in the Formula Student competition, we have to comply to all Formula Student rules. And these rules, they are very big. There's lots of technical details specifying how your car should look like. But still, there's quite a lot of freedom for the overall vehicle choice. So, before we could start designing a car, we had to determine what kind of car do we want to design. As Bas already mentioned, we want to win. The goal is to win the competition by focusing on the dynamic events. So that means we want to build a very fast car. Now, what makes a car really fast? Is it the color? Is it maybe the driver? Or is it the size of the rims? Actually, no. The entire complexity of the car can be brought down to its 2 main functions. 1, it should be able to accelerate in all directions, meaning it has to move from A to B. And 2, it should house our driver. Now that first function is what will determine the performance of our car. We want to accelerate forwards really fast. We want to accelerate backwards really fast while braking. We want to accelerate to the left and to the right while cornering. But that's not all. Another really important one is what we call yaw acceleration. This is basically a measure from when you're accelerating to one direction, how quickly you can go back to the other side. This is a measure of your maneuverability, of how agile your car is. From these 2 functions, we could determine our design philosophy, and that is lightweight. The lighter an object is, the less force you need to accelerate it. The smaller forces in turn mean the stresses in your components will be smaller, which allows you to make your components even smaller. From this design philosophy, we could conclude that the DUT16 will be a 4-wheel driven, electric-powered race car with aerodynamic devices and smart control systems. Now, you've all seen quite a few cool pictures of the car already, so let's go to the design step by step and see what's what. We'll start at the Vehicle Dynamics department. The Vehicle Dynamics department is responsible for the theoretical performance of the car. They make lots of complicated models and do complicated calculations to determine all kinds of parameters for the car. Even though they actually only make one part on the car, they have a big influence on all other departments of the car. As you can see from the picture, the tires are quite small, and I have one here with me. This will be the 3rd year in a row where we will be developing our own tires. These tires are quite small. They're 14.5-inch outer diameter. By designing our own tires, we can make sure that the tire fits the car the best. In this way, we can ensure that our car drives best, whether it's in the dry or in the wet. Now that we have the driver or the tires, we need something to place our driver. And that's where the chassis department comes in. The chassis department is also responsible for just one part of the car, and that's the chassis, the monocoque. Monocoque literally means single shell in French, and that is what it is. The chassis is there to carry all forces on the car, to house the driver, and in case of a crash, for driver safety. The chassis is constructed in what we call a sandwich panel. Now let me just explain to you what a sandwich panel is. It sounds kind of strange. What it is when you combine 2 materials with certain properties to get a new panel that has totally new properties. Let me just demonstrate. The bread of our sandwich is carbon fiber. As you can see, it's really lightweight, but it has almost no stiffness at all. It has a lot of strength though. When we combine this with the bread, or with the with the filling of our sandwich, which is aluminum honeycomb. This is also very light, no stiffness, no strength. It's just shaped like a honeycomb. We get the following. This panel, also really lightweight, is really strong and really stiff. This one was actually tested and it didn't break before we put a force of 1,300 kilograms just on this single part. Really impressive. The sandwich panels give us a tool to make a really lightweight chassis. By changing the number of skins and changing the thickness of the core, we can exactly determine where in our chassis we want the strength and the stiffness. Our chassis, out of the oven, only weighs 15 kilograms. This is light enough that you could bring it for free as hand luggage on a budget airline. Now that we have the tires and the chassis, we need something to attach to. That's where the suspension department comes in. Every wheel is attached to the chassis with 6 rods, making it 24 rods on the car in total. And these rods are strong, very strong. I brought one here with me. From this one rod, we could suspend not one suspension engineer. No, we could suspend all 11 of them 3 times. This means the forces on the car are immense, and that's true because of the high accelerations. Besides attaching the chassis to the wheels, the suspension department is also responsible for a really important thing on the car. And that's everything that has to do with the man-machine interaction. It's really nice to build a really fast car in theory, but you have to drive it as well. The ergonomics decide everything on the car from seating position to steering wheel position, all the man-machine interactions. The pedal box guys and the steering system guys then develop systems so the driver inputs are perfectly inputted. With the suspension, chassis and wheels in place, we kind of have a rolling chassis. Now we need something to propulse the thing. That's where the drivetrain comes in. And before I'm going to skip to the next slide, I want to explain to you what we mean with drivetrain. A good analogy is to compare the drivetrain to a mechanical watch. In a mechanical watch, there's hundreds of components, all working in tandem to achieve one goal, to show the right time. For the drivetrain, it's similar. There's lots of mechanical components, all working together to get the power from the motor to the wheels. Whereas in a normal car, you have one motor and one drivetrain to power your car, we have done it differently. We have placed a motor and a drivetrain in every single wheel. This means we don't need a big chassis to place our big motor, and we can sub it with 4 a lot smaller motors. Every wheel contains the motor, a transmission, and a brake system. Rather than going with a planetary gear set like before, we have come up with a totally new concept. By moving the motor closer to the edge, we could decrease the load path, making it an even lighter inner wheel assembly. To place a brake system in this inner wheel was quite a challenge. To keep the inner wheel as narrow and lightweight as possible, we had to rethink how to brake. Whereas normal cars brake by clamping a brake disc from 2 sides, we have only half a caliper pushing on the brake disc, and on the front, we even have 2 halves. With the motors in place, we need some kind of energy storage to drive the car. That's the powertrain department. The powertrain department has only 2 parts, being the accumulator, the battery of our car, and the motor controllers. The accumulator is probably the most dangerous part on the entire car. With 600 volts and 7.4 kilowatt hours, it's not strange that the powertrain department is dubbed the danger department. Now 7.4 kilowatt hours, I hear you say, what is that? A kilowatt hour is basically a measure of how much energy is contained. Now, just for an example, in my pocket I have my phone. If I charge my phone, it lasts about a day, if I'm lucky. If I were to connect my phone to the DUT16 accumulator, I could use it for over 3 years without charging once. Really cool. The way we do this is by using lithium polymer cell pouches. These cells are really lightweight for the energy that they contain. If we would build an accumulator to the same specifications with the normal battery that you have in your car standing outside, the accumulator would weigh over 500 kilograms, whereas now our accumulator only weighs 45 kilograms. I have to confess something though. With this amount of energy, we would not make it to the end of the endurance event. Probably after around 2/3 of the way, we would fall down, stop down with a fully depleted accumulator. This is where the trick comes in. Rather than braking with our brake discs, we brake on our motors. This is called regenerative braking, and in this way we can regain up to 30% of our energy. So now we have a lightweight accumulator and we can still drive fast the whole endurance. This is part of the motor controllers. The motor controllers, together with the control systems of the vehicle dynamics, control the power of every single wheel. And there's lots of systems working together to make sure the car is always driving the fastest as possible. We have a system which is similar to the traction control on your car, so it controls how much your wheels slip. But we also have really sophisticated things, like yaw rate control. This is basically sending different powers to the inside and outside wheels while cornering. Just to show off all the capabilities that we have with this, I brought a cool video. As you can imagine, an electric-powered race car must have quite a lot of electronics. And that's true. The electronics department is probably the most digital department we have. At the heart of the department lies the board computer, the ECU. The ECU functions as the brain of our entire car. By managing all the processes and calculations to keep the car running. Now, what's a brain without a nervous system? Exactly, that's where we have the wiring. The wiring, there's over 150 meters of wiring in the entire car. It makes sure we have one fully integrated smart system and everything is connected. Besides that, it also functions as a power supply for all the components. The electronics department is also responsible for something really important in motorsports, and that's safety. By controlling different aspects of the car, like for example the accumulator temperature or your accumulator state of charge, we know exactly in what state our car is and when we need to shut down the car and come to a safe stop. If we would stop here, we would already have quite a fast car. But we continued. The aerodynamics department. The aerodynamics department builds wings around the car to optimize the grip of the car. The way this works is a phenomenon which you're all very familiar with probably, from an airplane. An airplane has airfoil-shaped wings, and when they move through air, they generate a force upwards. What we have done is we have turned around the wings, giving a force downwards. Besides giving downforce, the aerodynamics is also there for lots of other things. By using CFD, this is computational fluid dynamics, we can exactly determine where the air is flowing around our car. We need a lot of processing power for this, but we thought of that. We have built our own cluster, a combination of 32 computers together, so we can do all our calculations in-house. Now, in this way, we can generate a lot of downforce on the car, meaning we can drive faster, but also really important in a race car is cooling. We can exactly determine how much air flows through our radiators and through our air inlets, so we always know we have the optimal performing car. A big challenge in aerodynamics is also how to attach the wings. Because we're such a big fan of suspension, we have combined the two. Our front wing is placed floating on the car, meaning it's connected to the wheels. Our front wing actually moves in tandem with the wheels, and I have a small picture to illustrate. On the left, you see the car running in normal operations. Now, if you would hit a bump or you would brake really hard, your front wing would move down, meaning it would touch the ground. What we have done is we have connected the front wing so it will move up. In this way, we can always have the perfect front wing position in every situation. The aerodynamics actually has 5 parts. First, on the front, you see the front wing. On the rear, you see the rear wing. On both sides, you have a side pod. And on the back, you have a diffuser. These wings generate so much downforce that at just a little over 100 kilometers an hour, you could drive upside down in a tunnel. This is something we will not test and not put into practice. One of the few things, actually. So, there we have it, the DUT16 design. With the tires, the vehicle dynamics, the really lightweight chassis of the chassis department, the suspension that always optimizes the car performance, the drivetrain to make sure we have the proper propulsion, the powertrain for the energy storage, the electronics to make it all smart, and the aerodynamics to provide extra grip. The DUT16 will be our weapon of choice to compete in the Formula Student competition this year. We're not there yet, however. In the coming 3 to 4 months, we will be producing and assembling our car. I hereby invite you all to come and join us on the rollout later this spring to show you the final end result. Thank you.
Whoa. Tom. Just wait. Tom, you forgot to mention something really important.
You are right. We have to thank everyone.
Firstly, really thank you to our sponsors. You guys are up there. It's quite a lot of them. Thanks to you. Without your help, we wouldn't be able to build this car. And we are really glad that you support us. Thank you. Thank you very much. A second special thank you goes out to the guys who have made these. The awesome pictures of the car that you have been looking at all night. Thank you, Leonard. Thank you, Yannick. Thank you, Niels. And thank you, José. You've done an amazing job. And the last person we want to thank is Irene from Siemens. She has moved a lot of mountains to get this presentation on track. Thank you. This is the point of the presentation where we say goodbye to the viewers on the internet. Thank you for joining. Great to have you. And now, there's still one really important group to thank.
Maybe the most important.
The most important. Tom, you do it.
Okay. This car wouldn't have been there without the team. So let's introduce the DUT16 team. Can I please have up front the aerodynamics department with Martijn van Hoorn, Rafael Giro, José Sanchez, Eduardo Saidi, Thijs van Veen, Tom Schultz, Luigi de Martino Norante, Varun Adichan, Simone van der Velde, Job van Zijl en Dick Soet.
And the chassis department with ook Martijn van Hoorn as well. Niels Wij, Kushik, Krishna, Simeon, Lander, Simon and Jonas.
The electronics department with Bernard Becker, Tu Hong, Joshua Jones, Alexander Mistorp, Veronica Wolczak, Michiel de Smet, Stefan Filippi, Gert Spek en Rutger van den Berg.